You might have heard of superfast broadband. It uses fibre optic networks that can deliver lightning-fast internet connections. But do we really understand how light delivers information, or where this amazing technology might take us in the future? Data is sent in fibre optic links using pulses of light. This light consists of an electromagnetic wave that is varied to encode information. But though we usually think of light in a wave form, light pulses are actually made up of millions of individual light particles called photons, the smallest packet of light energy. There's no such thing as half a photon, as photons are the smallest unit, the quantum particle of light. Physicists are only just beginning to catch up with the awesome potential of the small but mighty photon. But to understand and study them, they first need a way to generate them, one at a time, and that's pretty tricky. One method is to fire a strong pulse of blue laser light into a crystal. Because of the way the crystal affects the laser light as it moves through it, sometimes one of the blue photons from the pulse can turn into two red photons, each with half the energy of the original blue photon. Detecting one of these photons here, we know that its partner photon is over there, ready for action. But the process is random. The single photon could come along at any time. A more predictable way to make individual photons is to use an individual atom, but the photons come out in all directions. So, instead, scientists here in Oxford are building artificial atoms called quantum dots, which are made in such a way so that they guide photons to where they can be used. So now we have a single photon. What next? Well, the ability to generate and manipulate these quantum particles opens up a world of possibilities, extending way beyond optical communications. For instance, because single photons cannot be divided or tapped, like a phone could be, they can be used for unbreakable cryptography, which cannot be compromised by an eavesdropper. They can boost the power of biological imaging, and perhaps most excitingly of all, they can enable optical quantum computers, leading to the development of machines with greatly enhanced processing power.
Just you wait. Quantum photonics could change your world. To find out more about quantum photonics, visit www.oxfordsparks.ox.ac.uk.